Hello, Geometry. Chapter 8, Lesson 2, Proving Triangle Similarity by AA. AA is called angle-angle. Okay, so just like when we had triangle congruence, we had side angle side, side side side, angle side angle, all those. AA is just going to be angle-angle. So our essential question, what can you conclude about two triangles when you know that two pairs of corresponding angles are congruent? So the diagram here on page 226, you have two triangles, ABC and DEF. Okay, A corresponds to D, B corresponds to F. If that's 106 and that's 31, this is 106 and that's 31, that means C has to be equal D. So angle C has to be congruent to angle F. That would be, let's see, that's 137. Let's take 180 minus the sum of those two together. So 106 plus 31 is 137. Subtract those and that would be 43. Okay, so we know that third angles have to be congruent. Okay, so what can you conclude? Third angles are congruent. And you also will find that the sides are proportional. The sides are proportional, which means the triangles are similar. Those are the three things. If you have two angles that are congruent, we know that the third angles have to be congruent. The sides have to be proportional, which means you can set up a proportion, and the triangles are similar. So the sides being proportional, that'd be like saying, okay, if this side is 1 and this side is 2. If this side is 2, this side would have to be 4. And if this side is 3, this side would have to be 6. So this scale factor would be times 2. We can write a similarity statement just like we can with a congruence statement. So I could say triangle ABC is similar, ABC is similar to triangle DEF. Now make sure your corresponding angles must match up. So A corresponds to D, B corresponds to E, C corresponds to F. So the corresponding angles must match up just like we did with congruency. So I'm going to say corresponding angles must be aligned. Not maligned, but aligned. Okay? So if you have two angles congruent, that's the main point for here. That means the third angles are congruent, the sides are going to be proportional, and the triangles are similar. So when we go to page 228, that is what they refer to as the angle-angle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Now, a couple unique situations where this plays out. They like to use parallel lines with these sort of situations. So I'm going to make a triangle. It's A, B, C, D, E. That is not a D. There we go. What happened here? You can't see this. There we go. Bumped the mouse there. Okay, so angle-angle similarity. There's this triangle. You can pause it. You can take a moment to draw that out. So we have a set of parallel lines. DE is crossing through there. Okay. Now this creates similar triangles. What we have to remember is this angle here is going to be congruent to this angle here. They kind of form an F. It's upside down, but they do form an F. They are corresponding angles, and they're congruent. Okay? This angle has to be congruent to that angle. Again, corresponding angles on that side. And they all share angle B as well. So we can write a similarity statement here that triangle ABC, the big triangle, is similar to, there's your similar symbol, triangle. Okay, well, A corresponds with D, so I have to put that first. B corresponds to itself, and then E. Okay, so we have a similarity statement with those parallel sides. The other thing they like to do is, let's say these are parallel sides. And we're going to crisscross these. Okay. So we're going to call that A, B, C, D. That D is giving me fits today, E. So parallel sides. Now, again, what you get here is similar triangles. One is due because of alternate interior angles. So angle BAC is an alternate interior to angle DEC. That would form a Z. Of course, angle C is congruent to itself. Angle B would be congruent to this angle D up there. Okay, so you have similar triangles when you got this sort of shape happening as well, if you know those are parallel sides. So we could say triangle ABC is similar to triangle, call it out now, A goes to E, B was next, that goes to D, and then C. So they have to be in order. You can't just write them down in any old willy order that you want. Okay, so examples, question 2 on page 229. Determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. Your reasoning will most likely be the angle-angle similarity theorem. So we have a right triangle in ABC. That's 15. This one's 75. So if I find my third one there, I have to take 90 minus 15 since it's the right triangle. These two are complementary. Add to 90. And I get 75. So we got 75 degrees there. That corresponds to two angles here. So are they similar? Yes. If they are, write a similarity statement. The similarity statement is triangle ABC is similar to triangle, okay, A matches up with E, B is the 15, that matches up with F, and then C matches up with D. So triangle ABC is similar to triangle EFD. Explain your reasonings. And we'll just say we have two congruent angles. You could say the angle-angle similarity theorem. That's probably what the assignment's going to have for you. Okay. So three things. Determine whether they're similar. Yes, they are. We wrote a similarity statement. We gave a reason. Example 2. One triangle. We have 44 and 30. This one has a 30. So we need to see if this other one is 116, or in here we could see if that one's 44. So if I do 44 and 30, add them together, I get 74. I'm going to take 180 minus 74, and I get 106. 106 plus 74 would be 180. So that makes this 106, so they are not similar. Okay, this one would be 146, that would be 34 degrees there. So we do not have angle-angle similarity there. Okay, question 3 and 4, show that the two triangles are similar. So what we need to do here is state two sets of congruent corresponding angles. Now that's not necessarily corresponding as we had the F, okay, corresponding angles, but corresponding as in 8 corresponds to E, A corresponds to E, B corresponds to F, C corresponds to D. Okay, so this is the diagram we saw earlier. We have parallel lines. We know that angle A has to be congruent to angle DBC. So angle A has to be congruent to angle DBC. Notice I used 3 letters for that one because there's 2 angle B's. Angle A, that's the only angle. Okay, because they're corresponding angles with the parallel lines. Down here, I can say angle E is congruent to BDC. Those have to be congruent. They both use angle C. That's corresponding angles again. So we have triangle ACE, triangle ACE. ACE is similar to triangle BCD. Okay, there would be your similarity statement. Okay, angle-angle similarity. Okay, we have two sets. This is a parallelogram because opposite sides are parallel. We got lots of different options that we can go with here. We have a parallelogram. We could say angle P is congruent to angle R, because in a parallelogram, opposite angles are congruent. We can use alternate interior angles. So angle PQS, that would be congruent to QSR. Angle PQS is angle to QSR. Opposite angles are congruent. You could also use angle PSQ and RQS. You could also use those. Okay, so lots of different options there. So be careful with your naming here. So let's say I start with P. So triangle PQS is similar to, stop it, see if you can get it before I can get it, PQS. So P matches up with R. Q matches up with this one down here, which is S, and then you come up here, those three would go together, so RSQ. PQS is similar to RSQ. Alright, this diagram. Use the diagram to complete the statement. You'll have one similar to this. Okay, so measure of angle AGB. AGB. They want this angle right in there. So we have a 90 and a 63. So this angle has to be 90 minus 63, because those two angles should be complementary. That would be 27. So I'm going to say that's 27 degrees. 27. Label it on there. Now, when you get to this on your assignment, I highly encourage you to draw down the diagram they give you and start labeling it, and don't just use it off the computer screen all the time. This will help you keep track of where things are. Measure of angle EGD. EGD. Okay, now if you look, AD and BE are the two lines that form these vertical angles. So EGD is a vertical angle. That's going to be 27 degrees as well. So that's a vertical angle. The measure of angle BCG. Okay, BCG. BCG. Okay, so what do you think the angle of BCG is going to be? I think it's going to be 63, the same as over there. Okay. Now I want you to notice here, this is 6. Okay, this right here is 3. This is going to be an isosceles triangle. Okay, this is going to be on the perpendicular bisector, and if you have a point on a perpendicular bisector, it forms an isosceles triangle. So BCG is also going to be 63 degrees. Okay, so that takes care of the angle measurements there. AG, okay, so here's this length of this side. So you notice the two sides we have going here. This is 3. This is going to be 3 right here, because remember we have an isosceles triangle. That makes this a perpendicular bisector that going from here. Okay, what was I thinking about? No. AG. So AG, that distance right there, we have a triangle that has a side of 3 and a side of 6. We're going to use Pythagorean theorem. Okay, so the two sides, we have to take the square root of 3 squared plus 6 squared. Square root of 3 squared plus 6 squared. So that's the square root of 9 plus 36, which is the square root of 45. Okay, we get to review some of our simplifying radicals right now. If you remember from Algebra 1, square root of 45, that is 9 times 5, which gives us 3 and 3. You have a pair of 3's. So the square root of 9 times the square root of 5 is going to be written as 3. Square root of 9 is 3. There's a pair of 3's. 3 root 5. So that's how we're going to write this length right here. 3 root 5. You will have to simplify those. Okay, radicals can be simplified sometimes, just like fractions can be simplified. Okay, AB we already said was 3, right there. FE, remember this is 3, this is a perpendicular bisector, so that's going to be half of that, that's 1.5, or 3 over 2. ED is also going to be 1.5. Okay, GF. Now I want you to notice a similar triangles going on here. Okay, these create similar triangles, we've already talked about that. And GF is this length right here. So you see how this 3 is half of 6. So this triangle is half of this length. So if I take half, GF has to be half of AG. And we said AG is 3 times the square root of 5. That's 1/2 times 3 root 5. How that gets written is 3 root 5 over 2. 1/2 times 3 root 5 is 3 root 5 times 1 divided by 2. The 2 goes on the bottom. Okay. Now they're stating triangle AGC is similar to triangle. Now remember, A gets rotated down to D. So triangle DGC. AGC would go DGF. Okay, using the diagram for exercises 5 through 13, write the similarity statements for each triangle similar to triangle EFG. So EFG is this little triangle right up here, this little doohickey. Okay, so you may think it's similar to this triangle down there, but it's actually congruent to it. It's not similar. It would be similar to these big ones over here. So we have two statements we have to write. I'm going to start triangle EFG, similar to, okay, EFG, E goes to B, BAG, bag. Okay, let's write the other one, triangle EFG is similar to triangle, so EFG, E along the line then, so BCG. There's your similarity statement. Final question. Determine if it is possible for triangle HJK and triangle PQR to be similar. Explain your reasoning. Okay, on this one you want to draw out each triangle. It doesn't have to be to scale, doesn't have to be perfect. So HJK, let's call that H, that one J, and that one K. And PQR. So H is 100 degrees. K is 46 degrees. Okay, obviously not drawn to scale. That would make this one up here, this is 146, so 180 minus 146, that would be 34 degrees. Okay, so I have something to draw here. It says angle P is 44, angle Q is 46. Okay, 46 and 44 give us 90. 180 minus 90 is, again, another 90, so that's 90. So are they similar? We would say no. The angle measures are not the same. Okay, we'd say no, the angle measures are not the same. So a lot of your questions here, you can see the diagram that you're going to be having, similar to what we worked through on the examples. Show that the two triangles are similar. Okay, those sort of questions. There's your parallel lines, different things like that. Similar triangles show up in word problems. We can have some of those. You can always set up a proportion. Okay, so you have the good old flagpole problem, where you can use your shadow to determine the height of the flagpole once you know the length of the shadows. Once you know the length of the flag's shadow. Okay, so this is their diagram there. The sun's up here. You're 5 foot 4 inches, and you have a 40-inch shadow. This is X feet, and you have a 50-inch shadow. So they converted everything to inches. So X over 64. So X over 64 equals 50 over 40. They cross multiply, they divide, and you can find out that the flagpole is 80 feet tall. Okay, so that's a very common example for pardon me. Something turn on the sound. Apologize for that. Okay, very common example, solving the flagpoles, setting proportions with that. So similar triangles show up a lot of different situations, and they'll show up through some of our work and something like that. But I'll let you go. We'll see you in class.